we begin with an embryo. And inside this embryo, we find DNA. Geneticists have found a way to synthetically create strands of RNA that are complementary and anti-parallel to the gene that they want to knock out of this embryo. This piece of RNA was synthetically created by geneticists and is complementary and anti-parallel to the nano S2 gene in goats. The nano S2 gene is specific to male fertility, so the goal of this is to take that gene out so that the embryo can grow up to be a sterile male. This strand of RNA is the CRISPR part of the CRISPR-Cas9 system and is also called the guide RNA. This guide RNA provides specificity for the system, and what it does is it tells that Cas9 enzyme where to cut the DNA. Once again, we are in the embryo and there's this strand of DNA. So within this embryo, we have this enzyme called Cas9. This enzyme combines with that synthesized piece of RNA, and they combine to make the CRISPR-Cas9 system. And what they'll do is they'll travel around until they find that piece of DNA that is complementary and anti-parallel to that synthetically made RNA. What we see here is that piece of DNA was unwound by the complex. And we can also see that this strand matches up to be complementary and anti-parallel to that gene over there. So what now occurs is this enzyme will chop up that DNA. Now we can clearly see that that Cas9 enzyme has taken its molecular machete and chopped that double-stranded DNA right in half. What we can see here is that the Cas9 enzyme has successfully knocked out that nano S2 gene by cutting that double-stranded DNA right in half. So now what will happen is the cell will try to repair itself by non-homologous end joining. And it will pretty much try to stick or glue these pieces back together. And when this occurs, there's usually an addition or a deletion. So in this case, we're going to have an addition. So we add that base, and when we do that, a frame shift mutation occurs. So all of these will shift over, and now we have a mutation in the cell. So what we see here is that the embryo has gone through birth and grown up to be a sterile male. In this situation, the sterile male is known as the surrogate sire. So we also have a donor male in this situation, and this donor male has more desirable characteristics for what we want in goats. So as we can see, he's a little bit bigger than this goat and also has some more meat on his bones. So what has now occurred is stem cells have been taken from this more genetically desirable goat. And these stem cells, once again taken from this goat, are placed into the testes of our surrogate sire. So these stem cells have been transplanted into the testes of our surrogate sire. And if you remember right, stem cells can grow up to be So these stem cells have developed into spermatozoa. So now the surrogate sire is creating spermatozoa with the characteristics of our donor sire. And with this, the surrogate sire can now breed females, which come out to be more desirable.